In this module, we're going to look at classifications of matter, specifically the states of matter. And we have to start with some assumptions. First assumption is that all matter is made up of small particles. Then we're going to assume that those particles are held together by intermolecular forces. And those forces have different strengths depending on the nature of the material. And those forces hold those particles together. And those particles also have kinetic energy. You remember from physics that kinetic energy is 1/2 mv squared. We will say that temperature is the measure of the average kinetic energy of a system. So if we take all the particles at a given temperature, that will let us know roughly what its average kinetic energy is. The higher the temperature, the more kinetic energy. The lower the temperature, the less kinetic energy. Starting with those assumptions, we'll say that if the intermolecular forces are significantly greater than the kinetic energy, then the particles are held close together and they barely move, and this is called a solid. If the intermolecular forces are similar to the kinetic energy, then the particles are held close together and move freely, and this is called a liquid. And if the intermolecular forces are less than the kinetic energy, then the particles are not held together and they move very freely, and this is called a gas. So let's look at some examples of these. In these pictures, the first one is sodium metal. The second one is liquid water. Third one is oxygen gas. And we'll start working under the assumption that we are at 25 degrees Celsius. If you look at the sodium, it is a solid. The particles are still in their same structure. They are not moving freely. IMF is greater than KE. It is a solid. If you look at the water, the particles are moving around each other. It is not a rigid structure, but they're still close together. So the IMF is about equal to the kinetic energy. In oxygen, the intermolecular forces are greater than the kinetic energy, so it's a gas. We're heating it up so that it's 115 degrees Celsius. If we look at this, the sodium metal, those intermolecular forces are now being overcome by kinetic energy and it has reached a liquid state, so they're about equal. For water, the intermolecular forces are much weaker than the kinetic energy now, so the water is freely moving as a gas, and the oxygen, the intermolecular forces are still less than kinetic energy, so it is also functioning as a gas. Now we're going to cool everything down to negative 15 degrees Celsius. And as we cool it down, you can see that the sodium is going back to its solid state. We are getting a rigid structure, particles not moving very freely. So the intermolecular forces are back to being greater than the kinetic energy. In the water, it's starting to get a rigid structure, and the molecules aren't moving freely anymore but are forming an arrangement. So its intermolecular forces are greater than kinetic energy, and it is a solid. And if we look at the oxygen, it's still moving freely, the particles are still all over the place, so the intermolecular forces are still less than the kinetic energy, and it is a gas. So the assumptions we can make are that sodium has stronger intermolecular forces, water has moderate intermolecular forces, and oxygen has weaker intermolecular forces, and these forces are what allow it to have the states of matter that they are at the given temperatures. We can define the states of matter a couple of different ways. If we're going to look at a solid, the classic definition of a solid is to say that a solid has a definite shape and it has a definite volume. That means unless you act upon the solid with a force, its shape will stay the same, its volume will stay the same, and nothing will change. When we look at a liquid, we say it has an indefinite shape. Sometimes it's say it will take the shape of a container, or it is fluid. And it has a definite volume. So, like solids, water's volume or liquid's volume do not change, but the shape can. And when we get to a gas still has an indefinite shape, much like a liquid, so that's why both of them are defined as fluids. But gas also has an indefinite volume. Place a gas into a container, it will move, the particles will spread out until it fills the container. You'll just have more empty space. And because of that, a gas can expand or compress. So gases have compressibility. This ends the module on states of matter.